What is transmissivity and radiation heat transfer? Imagine sunlight streaming through a window and warming up a room. Have you ever wondered how much of that sunlight actually passes through the glass? That's where transmissivity comes into play. It's a key property that tells us how much radiant energy can go through a material without being blocked or reflected away. In the world of heat transfer, especially when dealing with radiation, transmissivity helps us understand how energy moves across different surfaces and materials. When thermal radiation hits a surface, it can do three things: get absorbed, reflected, or transmitted. Transmissivity, represented by the Greek letter tau, measures the portion of incident radiation that makes it through the material. For example, clear glass has a high transmissivity because most of the sunlight passes through it. On the other hand, an opaque metal surface has zero transmissivity because no radiation can pass through. This property is vital for designing systems like solar collectors, where you want sunlight to enter but keep heat inside, or in insulation materials that block infrared radiation to keep heat out. Transmissivity is related to other properties: absorptivity and reflectivity. Absorptivity tells us how much radiation a surface absorbs, while reflectivity indicates how much bounces off. These three properties always add up to 1. So, if a surface is highly reflective and absorbs little, it must transmit a lot of radiation if it's transparent. For opaque surfaces, transmissivity is 0, meaning all incident radiation is either absorbed or reflected. In practical terms, understanding transmissivity helps engineers decide what materials to use in heat shields, solar panels, or even in designing windows that maximize natural light while minimizing heat loss. It's especially important in systems where controlling heat transfer through radiation is critical. For instance, in spacecraft, where managing heat is vital, knowing how much radiation passes through different materials helps in designing effective thermal protection. To sum it up, transmissivity tells us how much radiant energy can pass through a material. It influences how heat moves in many engineering applications, from solar energy systems to building insulation. By understanding this property, engineers can better predict and control heat transfer, making systems more efficient and effective.